Good morning everyone. In last video we have seen about how to draw Lewis dot structures and how to calculate formal charge of each and every element present in a molecule. But in this video I am going to explain about limitations of Lewis octet theory. So Lewis octet is the number of electrons present around each and every central atom or atom present in a molecule. So though this Lewis dot structure have explained to some extent, still it is having few limitations, that is nothing but drawbacks which it is fails to explain. Okay, such drawbacks can also be known as limitations. Now we are going to study about limitations of Lewis octet theory. Okay, the first limitation is that according to Lewis theory, noble gases are stable. That's why they are not participates in the formation of any compound. So noble gases are containing, so these noble gases, for example I am taking here neon. So this neon is containing 8 electrons in its valence shell. That means already octet rule is satisfied by the noble gases. That's why they do not form in the formation of any bond or compound. So first limitation is that according to Lewis theory, noble gases are stable. Okay, they do not make bonds. However, noble gases also make bond as shown in the following example. So due to satisfied by its octet configuration, they should not participate in the bond formation. But few noble gases can involved in the formation of compounds, whatever I have written here. Example, chromium combined with 2 fluorines can form KrF2. Xenon combined with 2 fluorines can form xenon F2. In the same manner, xenon can also form xenon hexafluoride. Xenon can form xenon tetrafluoride, xenon trioxide. All these are said to be the compounds of these noble gases. Krypton, xenon are said to be noble gases. Though it is noble gas and balanced by its octet configuration, still it involves in the bond formation. But this point was not explained by the Lewis theory. So that it is one of the drawback of Lewis octet theory. Now we want to see the second limitation. There are some cases in which atoms do not follow octet rule. Okay, so he has explained that all the atoms should follow octet rule, but there are some atoms which do not follow octet rule. So while making the covalent bond, okay, so such compounds are classified into incomplete compounds, expanded compounds, odd electron compounds. First we will see what are incomplete compounds. Incomplete octets are the compounds which do not balanced by 8 electrons. If any compound is formed, that should follow octet configuration according to this Lewis theory. But here few compounds are incomplete octet configuration, that means they do not balanced by the 8 electrons. Example, we can take BeCl2. So central atom is Be because it is only in one number, it is in 2 number. That's why here we have taken Be. This is attached to 2 chlorides. Okay, so this chloride valence electrons are balanced, but the valence electrons are present in this beryllium is not balanced because here only it is with 2 bonds. Each bond is containing 2 electrons. Okay, that means 2 plus 2, only 4 electrons are there, but it should contain 8 electrons. Such 8 electrons are not there in the beryllium. So that is the drawback. That is, few compounds are formed without following octet configuration or octet rule. And one more example we can take for incomplete octet, that is boron trifluoride. So in this boron trifluoride, one boron and 3 fluorides are there. The central atom is said to be boron because it is only in one number and it is surrounded by 3 fluorides. That boron I have taken here. Okay, it is surrounded by 3 fluorides or 3 fluorine atoms. See, around this boron only 3 bonds are present. We know each bond is containing only 2 electrons. That means here 2 electrons, here 2 electrons, here 2 electrons. Totally 6 electrons are present around the boron, which is not balanced by the octet configuration. Okay, though this boron is not balanced by the octet configuration, still it is existing in the nature, but the reason is not explained by the Lewis octet theory. Okay, that is nothing but incomplete octet. Incomplete octet cannot be explained by the Lewis dot theory. Next, expand octet. Expanded octet means more than 8 electrons are present around the central atom in few compounds. Example, PCl5, phosphorus pentachloride. So among here two different types of atoms are present, that is phosphorus and chloride. So among these two, which is in less number, phosphorus, it is only in 1 number, chloride is in 5 number. So this phosphorus, due to present in very less number, that has to be taken as the central atom. Now this phosphorus is surrounded by 5 chlorine atoms. So each chlorine is bonded with the phosphorus by using a single bond. This single bond is containing 2 electrons. This single bond contains 2 electrons. Here 2 electrons, here 2 electrons, and here 2 electrons are present. So now see, around this phosphorus, how many electrons are present? Each bond is containing 2 electrons. 2 plus 2, 4, 4 plus 2, 8, 6, 6 plus 2, 8, 8 plus 2, 10. Around phosphorus, totally 10 electrons are present. That is, which is expanded by the octet configuration. Okay, this is expanded by the octet configuration. It should contain 8 electrons, but it is expanded by the 8 electrons. Totally it is containing 10 electrons. Why this is expanded by its configuration cannot be explained by the Lewis octet theory. And one more example we can take SF6, that is sulphur hexafluoride. The central atom in this case is sulphur, because here it is containing 2 atoms, sulphur and fluorides. 1 sulphur and 6 fluorides are present. Whatever the element which is in very less number, that has to be considered as central atom. Now sulphur is in very less number, that has to be considered as the central atom. Now the central sulphur atom is surrounded by the 6 fluorides. 1, 2, 3, 4, 5, 6. Okay, clear? So each fluoride or fluorine atom is attached with the sulphur by using a single bond. Okay, each single bond is containing 2 electrons. Now such type of single bonds, how many are present? 1, 2, 3, 4, 5, 6. So 6 into 2, 12 electrons are present around the sulphur. But actual number of electrons should be present according to Lewis octet theory is only 8. But instead of 8 electrons, sulphur is now containing 12 electrons, which is expanded by the configuration. Okay, clear? That's why these type of complexes are not following the Lewis octet theory. So, but the reason behind it was not explained by the scientist Lewis. Then we can take it as one of the drawback of Lewis dot theory. Okay, now we will see another type of complexes. Even odd electron molecules are available in the nature. So odd electron molecules are the molecules containing only single electron. Example, we can take NO. In this NO, nitrogen and oxygen, among these two, a double bond is formed. Between these two, a double bond is formed between nitrogen and oxygen. Now, within this double bond, 4 electrons are present. Remaining 4 electrons are present on oxygen as lone pair. And nitrogen here is containing 1, 2, 3, 4 electrons. And still it has only 3 electrons in its valence shell. Total number of electrons is 7. So totally that 3 electrons. Total number of valence electrons on nitrogen are 5. In that 5, 2 are involved in bond formation. Still 3 are there. Such 3 electrons can exist as like this. Among the 3 electrons, 1 pair can exist as lone pair. Another 1 electron exists as a odd electron. And there is no reason why this odd electron is existing on the nitrogen monoxide. Okay, that's why it is said to be odd electron molecule. In the same manner, even NO2 molecules can also exist with single electron. That odd electron molecules, why they are formed and why they do not follow octet configuration cannot be explained by the scientist Lewis. And again, this becomes one of the drawback or limitations of Lewis octet theory. And next one, this theory does not explain the shape of molecules. Till whatever we have studied, we have seen only about the compounds, okay, and whatever the charge present, formal charge present on the atom of each and every compound we have seen. But this theory does not explain about shape of molecule. Nowhere we have studied about shape of molecule, and it is silent about bond energy and stability of molecule. That means even it do not use the words bond energy and stability of molecule. These two words of related to the molecule is also not explained by the Lewis octet theory. Okay, then all these are said to be drawbacks. So this theory could not explain why the noble gases are involved in the bond formation, though it is satisfied by the octet configuration, and this do not explain about a few compounds which do not follow octet configuration. That means they involved in incomplete octet, expanded octet, or odd electron molecule. And this theory does not explain any shape of the molecule, and it do not use the word bond energy and stability of the molecule. Okay, now that is about the part of this chapter, that is Lewis dot theory. Now we want to know about coordinate covalent bond or dative bond. So this is one more important definition for 2 mark. What is coordinate covalent bond or dative bond? Coordinate covalent bond in which the both shared pair of electrons are donated by single atom. So here I am taking 2 atoms. Okay, usually a bond is made between the 2 atoms by sharing of electrons between them. So that means here 2 electrons are sharing between the 2 atoms. Okay, then that is known as covalent bond. But here we are studying about coordinate covalent bond. So this coordinate covalent bond is formed by the shared pair of electrons donated by only single atom. A and B we are taking. Now B is containing a lone pair of electrons. If this lone pair of electrons is sharing with the A, that means here both the paired electrons are donated by only one atom. So then that type of bond is known as coordinate covalent bond. A covalent bond in which both the shared pair of electrons donated by only single atom. Then that is called coordinate covalent bond or dative bond. A bond which is formed or covalent bond in which both the bonded electrons are donated or shared by only one atom, then that is said to be coordinate covalent bond, and it is also known as dative bond. Clear? So important for 2 marks. Next, bond characteristics. Whatever the bonds are formed between any 2 atoms, they are containing some characteristics. Now we want to know about the bond characteristics of different types of bonds. The first one is bond length. Firstly, we want to know about bond length. It is defined as the distance between the center of nuclei of 2 covalently bonded atoms. It is defined as the distance between what? The center of nucleus of 2 covalently bonded atoms. Now 2 atoms are covalently bonded. Just imagine each atom containing nucleus. Each atom is containing nucleus. Whatever the distance present between the nuclei, this is nuclei of one atom, this is nuclei of another atom. The distance between the nuclei of the 2 covalently bonded atom is called bond length. It is defined as the distance between the center of nuclei of 2 covalently bonded atoms, that is called bond length. See, bond length of HF is less than HCl. So because hydrogen and fluorine both are smallest atoms, whenever size of the atom is decreased, the bond distance between them also decreased and bond length also decreased. That's why HF is having shorter bond length than HCl. In HCl, Cl is the largest atom than the fluoride. So then the distance between the hydrogen nucleus and chlorine nucleus is little large when compared to the distance between hydrogen and fluoride nuclei distance. Compared to this distance is little more due to increase in the size of chlorine. Once the size of atom increases, automatically the bond length also increases. HF is containing less bond length than HCl, than HBr, than HI. So this is the first bond characteristic, that is bond length. It is defined as the distance between the nuclei of 2 covalently bonded atoms is called bond length. So bond length is always depends on the size of atom. Once the size of atom increases, bond length also increases. If 2 atoms whatever are bonded, if they are containing the smaller size, the distance between them also decreases. Bond length also will be very less. Now we will see the second bond characteristic. Before that we will see what are the factors affecting bond length. The first factor which affects the bond length is nothing but size of atom. Just now I have told you, once the bond length increases, bond length increases with increase in atomic radius. So once the size of atom increases, automatically the bond length also increases. Next, second factor is bond order. Bond length and bond order are inversely proportional. Bond order is nothing but total number of bonds between two atoms. The total number of bonds present between the two atoms is called its bond order. So that bond length and bond order are inversely proportional with each other. Bond length and bond order both are inversely proportional with each other. Once the bond order increases, bond length decreases. So bond order for fluorine is only 1 because two fluorine atoms are connected by a single bond. Bond order for oxygen is 2 because two oxygen atoms are connected by two atoms. Number of bonds between two atoms is 2, then bond order is 2. For nitrogen it is 3. Once the bond order increases, bond distance decreases. When number of bonds increases, those number of bonds can make the atoms present very close with each other. Okay, that's why once the bond order increases, bond length automatically decreases. FF bond length is greater than O double bond O bond length, which is greater than N triple bond N. Between two nitrogen atom, now triple bond is there, so this triple bond can make all the two nitrogens come very close with each other. But between fluorine and fluorine only single bond is there. That single bond will not make these two fluorine atoms present very close. So the distance between two fluorine atoms is more. Bond order is inversely proportional to bond length. And second bond characteristic is bond enthalpy. First bond characteristic is bond length. Now second one is bond enthalpy. So this is the energy required to break 1 mole of bonds between atoms in gaseous molecules. The energy required to break 1 mole of bonds between the atoms in gaseous molecules. Okay. So this is nothing but the amount of energy what we are taking to break 1 mole of bonds between the atoms in a gaseous molecule, that is called bond enthalpy. So your gaseous molecule is hydrogen molecule. Now H2 is in molecular state, in gaseous state. Now to convert these 1 mole of H2 molecule into 2 H ions or atoms, whatever the amount we are using, that is known as bond enthalpy. Now hydrogen is existing as H bond H. This is the H2 molecule. So here 2 hydrogen atoms are attached by using a single bond. If you want to convert it into H plus H, 2 atoms, we want to break this bond. To break this bond, to convert 1 mole of hydrogen molecule into its atoms, whatever the amount of energy we are using, that is called bond enthalpy. Such bond enthalpy for hydrogen molecule is 435 kilojoules per mole. For chlorine gas is 242 kilojoules per mole. For chlorine gas, to convert 1 mole of chlorine into chlorine atoms, whatever the amount of energy we are using, that is 242 kilojoules per mole. So this is called bond enthalpy, the energy required to break 1 mole of bonds between the atoms in gaseous molecule. Now we will see about the factors which affect this bond enthalpy. So 2 factors can easily affect the bond enthalpy. One is size of atom, other one is bond order. So first we will see size of atom. So size of atom is inversely proportional with the bond enthalpy. So once the size of atom increases, bond enthalpy decreases. So HF, HCl, HBr, HI we have taken. HF bond enthalpy is more, okay, because size of hydrogen and fluorine is very small. Distance between them is less, whereas hydrogen and Cl bond length is more. Distance between them is also more. When they are far apart to each other, attractive forces are less. To break that bond, it requires minimum amount of energy. But whenever the atoms are very small, they come very closer, and whatever the bond existing between them, that is very strong. to break such a strongest bond, it require more amount of energy. That's why bond enthalpy is inversely proportional to size of atom. Once the size of atom increases, bond enthalpy decreases. Size of atom decreases, bond enthalpy increases. In case of HF molecule, fluorine and hydrogen both are containing smaller size and energy required to the bond between them is very high. Now the second bond parameter factor which is used to explain about bond enthalpy is bond order. Bond order is directly proportional to bond energy. When number of bonds increases, energy required to break such number of bonds also increases. F2 molecule is having least bond enthalpy than O2 molecule than N2 molecule, because in N2 molecule number of bonds are increased. To break all these bonds, it require more amount of energy. That's why the bond enthalpy also increased. So that is about the second bond characteristic, that is bond enthalpy. This is nothing but amount of energy required to break 1 mole of bonds into gaseous atoms. Now we will see about the third bond characteristic, which is known as bond angle. So this bond angle is nothing but is defined as the angle between the bonds of atoms in the molecule. In molecule we can see atoms. Between this bonded atoms some angle is present. That angle between the bonded atoms in the molecule making covalent bond is called bond angle. Example, we can take H2O molecule. So this H2O molecule is containing 2 hydrogens and 1 oxygen. The bond angle between any 2 atoms, bonded atoms involved in covalent bond formation is 104.5 degrees. And in ammonia molecule, the bond angle between any 2 atoms is said to be 107 degrees. That means it is defined as the angle between the bonds of atoms in the molecules making covalent bond. And we will see now factors affecting this bond angle. So 2 factors can affect the bond angle, that is lone pair electrons and size of atom. First we will see lone pair of electrons. Greater the number of lone pair of electrons, lesser will be the bond angle. Whenever number of lone pairs, these are nothing but lone pair of electrons. Such lone pair of electrons whenever increases, automatically the bond angle decreases. Greater the number of lone pairs, because repulsions between the lone pair and bond pair increases, then bond angle decreases. Clear? When number of lone pair of electrons increases, then bond angle is decreased because of arising repulsions between lone pair and bond pair. Next, second factor affects the bond angle is nothing but size of atom. Greater the size of central atom, lesser will be the bond angle. When size of the central atom increases, the bond angle gets decreases, inversely proportional. Even this is inversely proportional. So that is about the third bond parameter and bond characteristic, which is known as bond angle. Next we will see the fourth one, that is bond order. It is the multiplicity of the bond between the 2 atoms in a molecule. Multiplicity is nothing but number of bonds. It is the total number of bonds present between the 2 atoms in a molecule is called its bond order. So bond order for single bond is just 1. Example, F2 molecule. So in F2 molecule between 2 atoms only single bond is there, so its bond order is just 1. Bond order is 2 for double bond. The double bond we can see in O2 molecule, that is between the 2 oxygens. And for triple bond the bond order is 3. It is example is nitrogen. In nitrogen 3 bonds are present between the 2 atoms, which indicates the bond order as 3. And here one thing you have to note down, that is greater the number of bonds, greater is the stability of molecule. When number of bonds increased between the 2 atoms, stability of the bond also increases. Okay. So in this video we have studied about limitations of Lewis octet theory, and after that bond characteristics, that is bond length, bond enthalpy, bond angle and bond order. Bond order is nothing but multiplicity of the bond present between the atoms in a molecule. Next, bond angle, it is defined as the angle between the bonds of atoms in the molecule. Bond enthalpy is nothing but energy required to break 1 mole of bonds between the gaseous atoms. Next, bond length, this is the distance between the nuclei of the 2 atoms in a molecule, that is called bond length. Okay, so these 4 definitions are very much important for 2 marks, and in next video we'll see about the next topic.